forget.
Okay. Okay. Refocus. So look at your sheet. Now listen, if we do this and we're focused, then we should have a little bit of time that if you didn't finish your homework, you can ask questions. Okay, or work on whatever you need to work on. So at the top, okay, the big thing that I want to drive home today is the difference, again, between average rate of change and average value, because a lot of y'all got this wrong on your test. So rather than starting here, we're going to start here, but it's not going to be done on your paper. Oops, so I'm going to get a different paper. Okay, but take your paper, your little packet, and flip it over. We're going to start with equations, and we're going to do graphs in a second. Okay, so take a look on the back. It says a particle travels along the x-axis with velocity v of t equals sine 2t measured in meters per second over 0 to 2 pi seconds. Suppose the particle is at x of 0 equals 3. Okay. Part A, what is the particle's displacement from 0 to pi 6? What do we do if we have velocity and we want displacement? Okay, so listen, average value is the average y value. So if it didn't say average, then don't do any averaging. Not it. There. Okay, kind of. Yes. Okay, so if this is velocity, displacement is position. Is that a derivative or an antiderivative?
Integral.
Integral. Great. Okay, so integrating from when to when? 0 to n? Pi 6. Now, the equation is from 0 to 2 pi, but we're only checking how far it moved from 0 to pi 6, yeah? So, integral 0 to pi over 6, and then we want the v of t, which is sine 2t. Okay, what method will you use to do that integral? U sub. Good. So, what is my u going to be?
2t.
Okay, great. U is 2t. What does that make du? 2. And then normally I would put my dt down here, but then I would cross it out and move it up, right? Okay, which means that dt is really du over 2. Great. So now we're ready to rewrite our integral with u stuff instead of t stuff. Okay? So this is now sine u. And then my du is over 2, but is it okay if instead of putting the over 2 here, I just put it in the front? Okay, since we've been doing u sub for a while now. So my 1/2 goes right here in the front. Okay, then, do I have any t's left?
No.
Then we're changing our endpoints. So my upper bound used to be a pi 6, now it's a 2 times pi 6. Okay, so my b used to be pi over 6. My a used to be 0. I have to change both of them. Okay? So if I'm plugging into 2t, that would be 2 times pi 6th. What is that really? Pi 3rds, good. Okay, now for the 0 endpoint, what's 2 times 0? Still 0. So the bottom endpoint doesn't really change, but that's fine. Okay, from there, equals, what is the antiderivative of sine u? Okay, so -1/2 cosine u. Question, do I have to go back to my 2t? No, that's why you change the endpoints, right? So I'm going to plug in pi 3rds and 0. Okay? So it'll be -1/2 of cosine pi 3rds and then -1/2 of cosine 0. Now, for my hand trick people, pi 3rds is here. Cosine's on top. I have one little finger on top, so it's a square root of 1 over 2, which would just be 1/2. So what is -1/2 times 1/2? -1/4. So I'm going to put down here equals -1/4 minus. Okay, now let's plug in 0. Cosine of 0 is 1, but then multiplied by -1/2 is -1/2. And then if I'm minusing negative a half, that's really plus. Okay? So is it a fourth plus a half? Negative a fourth plus a half, right? So this is negative a fourth plus 2/4, because 2/4 and a half are the same as each other. So negative a fourth plus 2/4 is 1/4. Okay, now it also asks you to interpret that in the interpret the meaning of that in the context of the problem. So if it's an integral, you should start with a period of time that we looked at. So I would say over 0 to pi 6. What is that measured in? Seconds. Okay, the particle position changed by a fourth of a meter. Okay? And actually, let me add one more detail to this. It changed by positive a fourth of a meter. Okay, so what did the particle do in that time period? Did it go forward or backwards a fourth of a meter? Positive, which would be forward. So either up or to the right, depending on which axis you're on. Okay, does that make sense? So if you integrate velocity, you're finding the change in position. Now, that particular thing you can call displacement, okay, because that's like a physics-y, it has a special name. Anything else, though, you wouldn't use the word displacement. Okay, go down to part B. Write an integral expression for the position at pi over 6. Okay, well, how do I find position if I have velocity? I would do the integral. So x of t equals the integral of sine 2t dt. Now, for this one, do I have a time interval? No, I have a specific time. So what I'm going to have to do is get the equation and then solve for my plus c. So I'm not going to redo all of the u sub. What was the antiderivative we put in the box? Okay, so it'd be negative a half cosine u, but then what would I have to change now that I don't have endpoints? Plus c. And then also, that's also true, I'm going to have to bring my original x back. Now technically it was a t, but you know what I mean. Okay, so it'll be x of t equals negative a half cosine 2t plus c. Now, it is not truly a particular solution if you don't know what c is. So look back in the question. What detail did they give you that will help you find your k? Right here, good. Says x of 0 is 3. That means that 3 is the answer when I plug in 0 for my time. So I'm going to put here, given x of 0 equals 3. And remember, why do I need that to find my c? Yep. So I would say 3 is the answer when I plug in 2 times 0 plus c. Okay, well, cosine of 2 times 0 is cosine of 0. Cosine of 0 is how much? 1. So if that's negative a half times this is really a 1, then it's just really still a negative a half plus c. Okay, then what is my c value? I'm going to add the half over 3.5. Very good. So my c is 3.5. Okay? Is that good enough to leave it all chopped up in pieces on your paper? No, your final thing that you have to do is write the position. So x of t equals negative a half cosine 2t plus 3.5. Now, did they give you a particular time that they wanted for your time? Pi 6. So then I would put negative a half cosine 2 times pi 6 plus 3.5. What is 2 pi 6 the same as? We did it earlier. Pi thirds. So really this is negative a half cosine pi thirds plus 3.5. What is the cosine of pi thirds? So you're on this finger, but you want the top, it'd be a half. So that's negative a half times a half plus 3.5. What is half times a half the same as? Negative a fourth. Can we turn that into a decimal since we used a decimal here? So that'd be 25 cents plus $3.50. What's 350 minus 0.25? Make it like money. You have $3.50, you take away a quarter. Great. Okay, now, on the AP test, I lose a point. Out of 9 points, I would have lost one because why?
Units.
Okay, I like that you're thinking about units, but it actually, normally it would say in the question, make sure to include units in your answer. So it doesn't say that here. It's something different, but that's a good thing to point out.
What's on the other side of the equal?
Okay, yes, so when you do an equals, and this is like a dork math thing, okay, but if I put an equals here, that means that it's equal to what's above it. Okay, equal to what's above it. Equal to what's above it. Is this line equal to this line? No. This is at t. What is this at? Pi 6. So you will lose a point for that on the AP test. Okay, because these two things are not equal to each other. One of them is at any time. One of them is at a specific time. Okay, so it's kind of like an extra, rule or whatever that they have. That if you put in equals, the two things between them better actually be equal or you lose a point. Okay? Yes?
Since you mentioned units,
Uh-huh.
assume it's meters. They never actually describe what.
It actually does say up here that it's meters per second. So when you integrate meters per second, it would be in meters. So that's a good thing. Let's go ahead and add that here since you guys noticed. When you integrate meters per second, you get meters. Yes, ma'am?
So you plug in the 0, 3 point first, and
Uh-huh.
then you find the C, and then you plug in the time you gave me?
Yes, and the reason why is because I can't plug in pi 6 when I don't know what C is, and it doesn't help you find C to plug that in. It actually makes it more work. Okay? Alright, so the last little section, I want you to write what each of these are. I don't actually want you to find them. I don't need you to do it in the calculator. Some of them are integrals. Some of them are average rate of changes. Some of them are average values. So I want you to just write an expression for those last 1, 2, 3, 4, 5 things. Okay? Now one of them is a repeat. We already did displacement in part A. How did we find displacement? You did the integral, right? Okay, so that one's the same as part A. We just did that. So displacement is the integral. Now I want distance traveled. What is the difference between distance traveled and displacement? Absolute value. Okay, distance has to always be what? Always positive. So I'm going to do the integral from 0 to 2 pi of v of t like that in bars. Okay, next thing. Okay, I have 3 averages. I have average velocity, average speed, and average acceleration. One of them is AROC, one of them is average value, and the other one just take a guess at. Okay, I'm going to give you maybe like 15 seconds. Think about it. Which one's AROC, which one's average value? Okay, so what equation were you given? What do you already have? Velocity. If I want average velocity, is that average rate of change or average y value?
Average value.
Hey, good, you got it. 1 over 2 pi minus 0, integral 0 to 2 pi, v of t dt. Okay, why is it average value? Because you have velocity, you want average velocity, that's a y value. Okay, look down at part F. This time I want average speed. What's the difference between velocity and speed? You need absolute value bars. What is speed? It's always what? Positive, right? In your car, you have a speedometer, not a velocityometer, because that's not, I don't think, a thing. Okay, when you go backwards, it tells you how fast you're going backwards as the speed. So all that I need to do for average speed is that. Okay, you just take whatever your average velocity is, put bars around it, and that'll turn it into average speed. Okay, then the last thing is average acceleration. I have velocity. I want average acceleration. Is that a y value or a slope? This is an average slope or an average rate of change. Remember, slope and rate of change are the same. So I would do, tell me if this is right or wrong. A of 2 pi, A of 0. Don't write this down. Hint, it's wrong. Why is it wrong? Okay, you're not doing the slope of A. What are you taking the slope of? V. Okay, a lot of y'all are doing that on your test over and over again. Those should be V of 2 pi. Because what are you taking the slope of? Velocity. Okay? So it'd be V of 2 pi minus V of 0 over 2 pi minus 0. Got it? Okay, turn over, please, to the front page. Now we're going to do it with a graph. Okay? So instead of having an equation where you might have to do U sub and stuff, you have a pretty little graph. What's in the graph? Velocity. What's it measured in? Okay, meters per minute. Velocity measured in meters per minute. Okay. You have done enough of these that you should be able to do some of it. There is an average value. There is an average rate of change. I'm going to come check your homework, and I want you to just give it your best shot. Okay? And if you finish it easily, you can go to the one on the back. So homeworks that I'm checking are 9 and 10. 9 was optional, 10's not. I do. And you guys can work together if you want.
Wait, that one you just do you stuff. That's your. And then what's the derivation of that? And then what's going to happen? The 2 is below the bottom. And then the 2x and 5x dx is crossed out. That's just the normal use of, yeah. It's kind of like mixed up to trick you on this. So, and then this one is arctangent. You see how it's a squared plus u squared? You just don't really need use that since your u's just under. You pull it to the front. So it'll be 6 in front, 1 over 4 plus u squared, yeah? And then from there, you just do your antiderivative, which will be the arctangent.
I also have other ones.
Are they done, or you need help with them?
I think they're done.
Okay, I'll come grab them from you. Homework. Good. Thank you, sir. And then this one is just normal use of. So you'll pick that. So that one you don't actually need long division on, since it's not polynomials. Homework. Working on it. Yes. Oh, yes, there is a paper, and I did record it, and I will give it to you. But I will probably forget after I finish checking this, that it just reminds me. Me, do you have homework 10?
I got the homework. You reminded me.
Good.
I was just
Any homework over here? Okay, just thought I'd ask. I haven't given up on you yet. Homework? Homework? Great, love it. 10.
I want to download the
What's
garden
this?
whenever I'm bored, like, or run out of line.
One of them I still need help on.
Okay.
And then
Which one is it?
this one. I don't know which transition.
Pick Cotan. Cotan X. And if you look on your pink sheet, oh, is that your 9? Flip it over. And then when you take the derivative of cotan on your pink sheet, it's negative cosecant squared. Homework? Homework? Not today. Homework?
This needs a lot of work. It takes 2 stars for a week to fall. I wish. You know how you buy like cookies and buy like stuff. I wish you buy stars.
I wish you could buy homework. Do your homework.
I didn't do my number, but a number what?
Okay, irrelevant to me. Completely irrelevant.
Not
9 and 10. Yes.
And
Dina? Yes.
they could have downloaded the
I
card.
do. I haven't opened them, but do you want to go get them? Go, you see that black long shelf? It's bottom left hand, and you'll see on the right there.
Oh, yeah, I see.
I didn't see it out. Do you have it?
It's like your
Okay. You should be actually getting your homework. Okay, cool. So I'll just check you out for 9. Any homework? APOL. Have you even started the homework? Or
I have like 2 problems left.
okay, 2 out of 8, so a 4.
Yeah.
Okay. Just thinking about it. Yes.
I got this wrong.
Celebrate the little
When I
bits.
explained. I thought I didn't read it up in 22.
Okay. Tell me what you would say.
I don't know. I mean, this is kind of like. It's kind of on the spot. Yeah.
Okay. What are your units? You have your homework.
Meters per minute. And
Okay.
it goes in meters.
Integral is meters. Okay. And then what's movies? Okay. So then you would say the number of meters that the car traveled over what time
The
interval?
integral of what? Of the
Okay.
time interval of this.
Yes.
That's it?
Homework.
And which one is it?
Zeus, what are you doing with your life? Homework?
Which one is that it?
I mean, yeah, that's it. Now you need to make sure you put units into it.
But it doesn't say units on here.
So it actually says interpret the meaning.
Which means
That
that's the unit.
implies, now on the AP test, usually they'll say include units in your interpretation. So I did not say that, but.
Wait, what was the thing?
You were gone yesterday? And then, I think you already got the link right now. We did this in one video,
What is it?
and the little short video.
I have one
And then Eileen, you said you finished old homework.
right now.
There you go. You got Starbucks, right? I mean, he didn't lie, you got Starbucks.
Thank you, sir.
Where did you go?
I'll take what you got.
Brandon, where did you go?
Some other. I think
Was the vending machine in the restroom?
Okay, Brendan, what are you doing? Where'd you even get that?
I'm so
In
tired.
the bathroom?
He went to Starbucks. Mr. Strong's room.
Not proud of you. Okay, what's V of 8? Let's see how you did. Okay, great. Say, I heard a 20 from Olivia. So V of 8 is 20. Okay, then it says interpret the meaning and include units. What is velocity measured in? So 20 meters per minute. Okay, now let's interpret. Now, for integrals, I have to say over a period of time. For V of 8, am I looking at a period of time or one time? Okay, so at t equals 8 what? Minutes. Okay, then what's my velocity of? A what? A car. So car is traveling 8 meters per minute. Now, actually, let me add one other thing. Is the car traveling forward or backwards if his velocity is positive? Oh, wait, it was 20. Thank you. Okay, so at t equals 8, the car is traveling forward at 20 meters per minute. Now, how do I know the forward? Because 20 is positive. What if his velocity is negative? He would have been going backwards. Okay, part B. Evaluate the integral from 0 to 24. Did anybody find the area? Please, you already did it? Anybody? Huh? What? How much? Nobody did it? 360, thank you. Okay, so integral from 0 to 24, v of t dt equals 360. Now, let's talk about, okay, that if I'm thinking about units, this is area. How do you find units for area? You do length times width. So my length is measured in what? And my width is measured in? So if it's meters per minute times minutes, what are your units for the integral? Meters. Okay, now let's interpret. Should I say at 24? No, what should I say? Over 0 to 24. Okay? So over 0 to 24 minutes. Remember that integrals are over an interval. Ooh, okay. Over 0 to 24 minutes, the car's position changed 360 meters. Now, could you say the car's displacement is 360 meters? Sure, that's fine. Okay, but remember that the integral measures what the antiderivative is, how far it changed. So my antiderivative is position, that's how much the position changed. Okay? Alright, go down to part C. I want average value, that's 1 over 24 minus 0, 0 to 24, v of t dt. Now, don't do extra work again. Okay, we already found the integral. How much was it? Over 24. Did anybody divide that? I think it's 15, yeah. Okay, now let's talk about units real quick. On the top, what was 360 measured in? Meters. But what is 1 over 24 minus 0 measured in? Minutes. So notice that what happens to your units when you do average value? They end up the same. Okay, think about this is the average y value. So if y value is in meters per minute, the average y value should also be in meters per minute. Good? Okay, now draw 15 into your chart. 15 is here. Okay, was he above the average for part of the graph? Was he below for parts of the graph? Okay, yes. His average should be between the extremes of his velocity. So for part of it he was going 20 miles per hour, for parts of it he was going slower, but the average speed of his journey was about 15 miles. So he's like in the alley or something. Okay, going nice and slow. Okay, then it says include units in your answer, explain the meaning. So I would say over 0 to 24. Oh, minutes. Okay, car is traveling at an average velocity of 15 meters per minute. So his average speed is 15 meters per minute, even though he was going faster than 15 and slower than 15 at different parts. Okay? Alright, go down to part D, v prime of 8. What is v prime if we have a graph of v? That's the slope. At 8, what's the slope? Okay, v of 8 is 20. What's v prime of 8? 0. Okay, because that's the slope. Okay? Now, for my interpret, what does v prime tell me? It tells me how fast v is changing. So if v prime is 0, does that mean the car's at rest? No. What does it mean about its velocity? It's not changing. He's not increasing or decreasing. His velocity is steady at 20. Okay, and if you look at the graph, you can see that that's true. For this time interval, he was going at a constant velocity of 20. So I would put at t equals 8 minutes. Velocity is constant at, what is it at? 20 miles per hour. Or not miles per hour, meters per minute. It is not changing. Okay? So if the slope is 0, that just means whatever your crap is staying the same. It's not going up or down. Okay, then the last part says find the average rate of change from 0 to 16. What is that? A-rock. Very good. So I do V of 16, V of 0, 16 minus 0. Okay, then from there, V of 16 in my chart is 20. V of 0 is 0. 16 minus 0 is 16. So I'm going to just leave it like that. Now, units. This is the rate of change of the velocity. So if it's the rate of change of velocity and the velocity is meters per minute, what's the units? Meters per minute squared. Okay? Then it says to explain the meaning of the average value. Then what would you say? His average acceleration is 20 over 16 meters per second squared. Now, let's look at the graph again for a second. Okay, is his actual acceleration or slope, is it 20 over 16? No. But it's saying that if I average this slope and 0, that's the average slope of the graph from here to here. Okay, that is the average of those two slopes. Is 20 over 16. Okay, so the average for part of it is 0. The average for part of it is whatever that is. 20 over 2 is 5. And then if I average those over how long he traveled those, that's his average. Okay. So we would say over 0 to 16 minutes, the average acceleration is 20 over 16 meters per minute. Another thing that you could have said that maybe would be better would be to say the velocity overall had an average change of 20 meters per minute squared. That would be fine too. Okay? Alright, turn the page. Turn the page. Okay, what's in your graph this time? Okay, what thing are we measuring? The acceleration. Okay, so for part A it says find A of 7. What's A of 7 in the graph? Okay, good. It is 0. Does that mean the car wasn't moving? No, it means his acceleration was 0. So he wasn't speeding up or slowing down. He was staying the same. So A of 7 equals 0. And what is acceleration the slope of? Velocity. So I would say at t equals 7 minutes, velocity is constant or not changing. Okay? And then actually let's put velocity in miles per hour is constant or not changing. Okay? So if your acceleration is 0, that means you're staying at whatever speed you're at. Now, question, do we know his speed? We don't know what the velocity graph is, but we know that he wasn't speeding up or slowing down. Okay, go down to part B. I want A of 8. A of 8 is down here. What is the value of A of 8? -1. And that would be, look at your units here. miles per hour per minute. Okay, that's kind of a weird one, but I want you to think about what that means. At time t equals 8 minutes, the velocity is increasing or decreasing? Decreasing. Why? Because it was negative, right? At 1 mile per hour each minute. So that, or you could put miles per hour per minute, but I wanted to break down what that means. So that means that at that time, he's slowing down 1 mile per hour every minute. Okay, so that is still an acceleration, even though it's kind of a weird unit for it. Okay? Okay, then for part C, integral 0 to 9 of a of t, how are we going to do it? Take the antiderivative, which is area. Yeah? So, find this one and find this one. Okay, top one is a trapezoid. Obviously, right? Okay, and then this one is a triangle. Okay, 1/2, top base is 4, bottom base is 7, height is 4. So that'd be what on top? Oh, dang. Thanks. Okay, 3 plus 7, which is 10, so that'd be 20. Okay, then bottom one, what's your triangle? How big? 2. Okay, so what would I put for my answer for C? 22? 18. Okay, 0 to 9, a of t dt equals 18. Because remember that without absolute value bars, you have to take whether it's above or below. So 20 take away 2 is 18. Okay, then for my interpret the meaning, I would say over t equals 0 to t equals 9. I don't know why I wrote it like that. You could just put brackets. Okay, over 0 to 9 minutes. Now, if it's the integral of acceleration, what's that called? So this is how much velocity changed. Did velocity overall increase or decrease? 18. Increase, because why? Most of the area was above, positive. So I would put velocity increased 18. Now let's talk about units for a second. Okay, when I do area, it's length times width, right? If I did miles per hour per minute times minutes, what is left over? Miles per hour. Now, is miles per hour how velocity could be measured? Yes. Okay, so even though it's a weird unit, when you multiply miles per hour per minute by minutes, they still cross out with each other. Okay, so overall, from 0 to 9, the velocity increased 18 miles per hour. Okay, skip down to part E for a second. Okay, it says, given that at time 0, the car was at a velocity of 10, find the velocity of the car at 9. If I have acceleration and I want velocity, that's an antiderivative. You would make a table. So come up here to the top. What is my starting velocity? 10. So at the top of my chart, this is for part E. Time 0, 10 velocity. What else goes in my chart besides the starting point? The end point, which is 9, and anywhere that it changes sign. Where did it change sign? 7. So from 0 to 7, how much did my velocity go up? What's my area? 20. So if it was at 10 and it went up 20, then where is it at 7? 30 because it went plus 20. And then from 7 to 9, maybe, I don't know, he saw a cop and slows down. How much did he slow down? 2. So he would be at what speed? 28. So at 9, what was his position? 28 miles per hour. Very good. So V of 9 equals 28 miles per hour. Okay, last part that we skipped, part D. Find the average value of the function from 0 to 9. What are we doing for that? Average, okay, so average value would be which one? 1 over 9 minus 0, 0 to 9, a of t dt. Okay, we already did the integral from 0 to 9. What did it come out to be? We did it in part C. 18, so I want 18 over 9. What does that divide out to be? 2. Now I want you to draw 2 into your graph and see if that could be the average. Okay, if I'm looking at my graph here, okay, and I draw in 2 miles per hour, that'd be here. Okay, could that be the average of my graph? Yeah, because he's above it for part, he's below it for part. So my average is 2. Okay, so then it says to interpret your units. Okay, I would say over 0 to 9 minutes. The average velocity, not velocity, the average what? Acceleration is 2 miles per hour per minute. Okay, and I want you to think about units again here. Okay, what did we say our integral was? Our integral gave me miles per hour. But then when I put 1 over 9 minus 0, that's in minutes. That's why it goes back to miles per hour per minute. Does that make sense? Are you all confused or you get it? Get it? Okay. So I don't need you to do the other one. You have a couple minutes left. If you want to do it, you can. But if you are going to do it, let me correct one little thing on it. It says miles per hour per second squared. That's a little much. It should just be miles per second squared. So if you want to do it, I support you. Okay, but I need to see your homework and stuff. You have like 6 minutes. Okay, good. Now, one other thing on the AP test, they probably won't leave it as 1 over cotangent. What's 1 over cotangent? Tangent. So it'd be negative 2. Now, you don't have to fix it. And then that would make sure you switch it back. Should it be a U and U? Wait, hold on. Something didn't work on this one. Your U needs to be square root x. Make it x to the way you are. And so then what's the derivative? Because think about it, you can't have a square root x left over in your answer. So let me get a sheet of scratch paper. Is it sine or cosine of the square root? Okay.